Welcome friends. In today's video, we are going to see JVM architecture. So this become the important question when you go with freshers. Interviewer may ask you like what is JVM and what is the architecture of JVM. So this thing we are discussing in this tutorial. Stay with me. We will discuss like what is class loader, bootstrap class loader, how many memory spaces is there. That all we are going to see in this video tutorial, as well as we will see JVM architecture as well as memory areas and garbage collectors. These become the important concept for the JVM architectures. So let's understand here a JVM architecture. First, we will see this diagram here before going to the definition. Uh, Here, if you see, they have given some areas, memory area is there, class loader is there. So class loader, what it will do? Loading, linking, and initialization. It will do up our class. Means whichever program we are writing or class we are writing that done by the loaded by into the JVM by this class loader. Then this method, this runtime data area is there. Like whenever we declare any variable or we create any objects that are getting stored in these memory areas, so that are specific to the like a method areas, heap areas or stack areas, which data it is going to store we will see in the further slides. Then there is execution engine. Execution engine is it is a interpreter, a JIT compiler and garbage collector. And this engine will run our Java programs and it will compile our Java code into the byte code. It will run garbage collector as well. It will interpret our Java code to the machine. Machine means hardware. So that these are they have given in execution engine. And then a native method interface is there. This we will see in upcoming slides. Let's understand what is JVM. So JVM stand for Java Virtual Machine, is a software-based platform that enable Java program to run on various operating system. Means this JVM will do run our program on different systems. Then it act as a intermediary between the compiled Java bytecode and underlying hardware. Means our bytecode it will compile, then it will run on any hardwares. Means Java is a platform independent because of this Java bytecode. Then providing a consistency execution environment regardless of underlying system. Means it will provide consistent execution environment for Java program. The JVM plays crucial role in execution of Java program, managing memory, executing bytecode, and providing security features. So security features is also provided. We have seen here memory areas. We will discuss further in further slides. It executes our program into the bytecode. Let's understand further. Here, class loader, we will go in depth with each component here. So stay with me till the videos. You will understand in depth. You will get in depth knowledge on the JVM architecture. If interviewer ask any question, so you can, if you explain few points as well, then it will that will be satisfied answer to the interviewers. So understand this class loader. The class loader is responsible of loading classes into the JVM. As we have like previously, they have given class loader. So the work of class loader is to the load class into the JVM. It dynamically load classes as needed, preventing the need to load all classes at the start of execution. Means it will load our classes dynamically. There are three types of class loaders. So here if you see bootstrap class loader, extension class loader, and application class loader. These all three have different use cases. Yeah, what it will do, like bootstrap class loader, find class is loaded by bootstrap class loader. Then this will also same here diagram you can see. And here a usage they have given. Then the bootstrap loader loads core Java classes. Here use of the bootstrap class loader is load core Java classes. The extension class loader handles classes in Java extension directory. Extension class loader will handle classes in extension directory, and system loader will load the classes in the class path. So which are the classes available in the class path that load by the system class loader? What is the use of this class loader? The dynamic loading. It will load classes on demand and improving performance of the loading necessary classes. Means which are the classes is required. It is loaded by dynamically by class loader. It provides securities as well, restrict access to sensitive system resources by controlling class loading and execution. The namespaces maintain a separate namespace for each class loader, preventing class name conflicts. So it will avoid class name conflicts by maintaining separate namespaces for each class loaders. Delegation, delegate class loading to the parent loaders, ensuring that core classes are loaded from the correct location. So it will ensure that correct class is loaded from the correct locations. And then these are the runtime data area. Here we are going to see which means where our objects are get stored or where our data gets stored. So the runtime data area is a memory region where the JVM store data and resources necessary to the program execution. So that are resources are required to execute our program are stored in this runtime data area. So these are divided into different components, each with specific purpose. The component work together to provide execution environment for Java programs. So what are that areas? Method area is there, heap is there, stack is there. So method area store the class information, including bytecode, constant pool, and static variable. Whenever we declare static variable that are getting stored in the method area, or any class we declared that are stored in the method area. So then heap area, heap area stores all the object created during program execution. Like suppose we create a box equal to new box. So which are the object we are created with the keyword of new are stored into the heap area and managed by the garbage collector. Garbage collector, what it will manage? If the reference is null, garbage collector will the remove or destroy that object and release the memory space. So that is space is available for the new objects. And then stack stored local variable, a method parameter, return addresses, and each thread. So stack will store the information of local variable which we are declaring. Then method parameters, method we pass method as a parameter that also are getting stored into the stack area. Return addresses and each thread. So thread information will be stored into the stack area. So this also you can mention in where this data is getting stored. Then here execution engine, what execution engine do? It interpret with our bytecode as well. Here if you see, execution engine is responsible for executing Java bytecode. It interpret and translate bytecode into the machine instruction that the underlying hardware can understand. Means what it will do? It interpret classes bytecode into the machine instruction. Machine instruction means like that we use 0101. So bytecode it will convert that into the machine code that hardware can understand. Hardware can understand only 0101 because that we stored into the binary format only. The execution engine can also perform optimization such as just-in-time compilation to improve performance. So it in just-in-time compilation. So this is the feature of Java language that will convert our code into the bytecode in just-in-time due to this just-in-time compiler. Then interpreter executes bytecode execute instruction by instruction, providing portable execution environment. So what it will do, interpreter will do executes our bytecode by instruction. Means each instruction will be uh, executed by the interpreter. Then JIT compiler is there. JIT compiler is just in time compiler. It will convert our byte source code into the bytecode in just in time with the help of this just-in-time compiler. Then here we will see. Then garbage collector is there. Garbage collector will reclaim unused memory space occupied by objects that are no longer reference. Means the object which you have null reference, that is collected by garbage collector, and that space is reused by the another new objects created. Then next we were going to see native method interface. This is a JNI. What is the use of this? The native method area enables Java program to interact with code written in other programming language. Means this will enable us to Java program to interact with the code written in like C, C++, other language. This allows Java program to access platform specific feature and libraries that are not directly available in the Java language. So it will allow Java program to access platform specific feature, that is libraries or that not directly available in Java language. Means we can use other libraries in our with the help of this JNI. Here are they have given function of this interportability. Allow Java program to call native method written in other language. So it will allow us to call other language platform specific access, provide access to platform specific feature and libraries not directly available in Java. Performance optimization enable developer to implement performance critical operation in native code for faster execution. So this is the use case of native method interface. And then memory management. How memory management is done in JVM? So JVM manage memory allocation and deallocation for Java objects. The garbage collector automatically reclaim memory spaces occupied by objects that are no longer reference. Means any object that is null has a null reference, that is collected by garbage collector automatically. So we don't need to run this garbage collector. It will automatically run and it will collect the reclaim the space, memory space in our in JVM. So preventing memory leaks and improving system performance. It will prevent memory leaks as well, because there is no longer use of that object. Means it will collect that and it will avoid memory leaks and improve system performance. So allocation, how it is done, objects are allocated memory space in the heap when they are created. So we have seen previously the objects are allocated in memory, that is when they are not used. Let's understand this. Then reference counting. The JVM keeps track of the number of reference to each object. When the reference count reaches 0, the object become eligible for the garbage collection. So how it will collect the garbage object which is becomes null, so it will keep the count of the reference. Means the object reference becomes 0, then that time it will, that object becomes eligible for garbage collection. Then mark and sweep. The garbage collector identify objects that are no longer reference and mark them for the deletion. So it will mark. This is the internal of the system, garbage collectors. So how it will work, they have given, and they then deletions. It then sweep the heap and reclaim the memory space occupied by these objects. Reclaim means that that space are being used by other objects. Then here compaction is there. After garbage collection, the heap may become fragment and just second. Unused memory spaces scattered throughout, and compaction rearrange object in the heap and create continuous free space. Then security, how the JVM provides security features that protect the Java application and the underlying system. These features include the bytecode verification, access control, and sandboxings. So what security JVM provides? Bytecode verification, access control, and sandboxing. Bytecode verification means ensure that bytecode loaded into the JVM is well formed and does not contain malicious code. Access control, so it will ensure that malicious code will not contain in the JVM. So then access control restrict access to system resources, preventing unauthorized operation and potential security vulnerabilities. Means it restrict the access to the system resources, preventing unauthorized operation and potential unauthorized access it won't provide. Then sandboxing, execute untrusted code in restricted environment, isolating it from the host system and other applications. So what is sandboxing? Here execute untrusted code in restricted environment. Means untrusted code it will execute in restricted, means specific restriction is given on that code, and in that only they have performed testing on that, and isolate it from host system and other application. It will isolate them from host system and application. Then just in time compilation, what is it? Just in compilation is a optimization technique used by JVM, and it improves the performance of the Java program. Instead of interpreting bytecode instruction by instruction, the JIT compiler dynamically translates frequently executed bytecode into native machine code during runtime. This result in faster execution speed compared to pure interpretation. So what it will provide? Speed it will provide to us, and it will dynamically translate frequently executed bytecode into the machine code during runtime. Then it will performance improve performance. What is the feature of this? Improve performance. JIT compilation optimized bytecode for native execution, lending significant performance gains. So due to this, we will get the performance. Then dynamic optimization. The JIT compiler analyzes the program execution profile and optimizes frequently executed code paths. Adaptive optimization. JIT compiler can adapt its optimization strategy based on program execution and their behavior. So these are the use cases of that. And then last but not least, the garbage collection is automatically. We have seen this previously as well. Automatically memory management process that reclaims unused memory spaces occupied the objects that are no longer reference. Means what it will do, the object that are no longer reference will be reclaimed by the garbage collection. It plays crucial role in preventing memory leaks and ensuring efficient memory utilization. So if it collect the memory, it collect unused reference, then that memory will be available for other objects. So that is the efficient memory utilization. Then JVM provides several garbage collection algorithm, each with strength and weaknesses. So these are the mark and sweep, copying, generational. These are the features of the garbage collection. So identify unreachable objects and mark them for the deletion. Then it sweeps the heap and reclaim the memory space occupied these objects. Then copying, divide the heap into the two spaces, from space and the two space. Objects are allocated in the from space, and when garbage collection occurs, surviving objects are occupied to the space. Then generational, divide the heap into different generation based on the object age. Younger objects are collected more frequently. So these are the different techniques of the garbage collections. Means these are the different garbage collection use a different algorithm to perform the cleaning and reclaiming the memory space. That's all from this video, guys. I hope you gain some knowledge from this. If you explain few points to the interviewer, he will satisfied based on this. Then thanks for watching this video, guys. I please like, share, subscribe to the channel. Notes I will share in our Telegram group. Thanks for watching.